Welcome, my dear students. Myself, Dr. A.Venkatesan, Assistant Professor, PG and Research Department of Mathematics, St.Joseph College of Arts and Science, Autonomous, Cuddalore. In this video, we're going to learn business mathematics from business mathematics. We're going to discuss a topic, a solution of system of linear equation. A solution of system of linear equation can be solved by two methods. One is matrix inversion method, another one is Grammar's rule. For any linear equation, you may write Ax equal to b. If you want to find the value of x equal to inverse of A into b. What is A inverse? A inverse equal to 1 by determinant of A into adjoint of A. What is adjoint of A? Adjoint of A equal to the cofactor of A, the transpose. Cofactor of A, the whole transpose. So if you want to find a solution of any linear equation, you must find the adjoint of A. From adjoint of A, you can find A inverse. From A inverse, you can easily simplify the solution of x. So now let us take the equation 2x plus 3y minus z equal to 9 and x plus y plus z equal to 9, 3x minus y plus minus z equal to -1. I take a linear equation 2x plus 3y minus z equal to 9, x plus y plus z equal to 9, 3x minus y minus z equal to -1. Sometimes the question may be asked instead of x, y, z, maybe x1, x2, x3. Okay. So from this equation, now I frame a matrix, coefficient matrix A. What is the coefficient matrix? The coefficient of x, y, z. So I take first equation coefficient. The coefficient of x is 2. The coefficient of y is 3. The coefficient of z is -1. Similarly, for second equation, the coefficient of x is 1. Coefficient of y is 1. Coefficient of z is 1. Similarly, third equation, coefficient of x is 3. Coefficient of y is -1. Coefficient of z is -1. And the x equal to the given variable x, y, z, and the b value is a constant. So 9, 9, and 1. So first we find the determinant of A. So the determinant of A is, you may write in determinant sense, 2, 3, -1, 1, 1, 1, 3, -1, -1. So the determinant of A you may express in the minor matrix form. So I take the 2. So now I omit the first row and first column. So from this one, we can easily write the minor matrix of 2. So 1, 1, -1, -1. Then negative of 3, you may take the minor matrix of A1, 2. So the minor matrix of A1, 2 is, so you remove the first row and second column, you can get 1, 1, 3, -1, and positive of -1. And now we find the minor matrix of A3, 3. So that time you can remove the first row and third column. So you can get 1, 1, 3, and -1. So 1, 1, 3, negative 1. Now we simplify the value. So how to simplify? If a matrix A, B, C, D, it can be expressed as AD minus BC. So therefore I can write 2 times 1 into negative 1, negative 1. Then as per the formula, you can write negative. Already you have negative 1 into negative 1. So negative 3 times negative 1, negative 3, negative 1 of negative 1, negative 3. So which implies negative into negative positive. So therefore negative 1 plus positive 1. So the value is 0. So therefore 2 times 0, negative 3 of negative 4, then negative 1 of negative 4 equal to 0 plus 12 plus 4 equal to 60. So the square matrix is a non-zero. So the determinant is exists. So therefore you can find inverse. So if you want to find inverse, you want to find the cofactor of A. So first I find the cofactor of the first A1. So for by convenient, I also again write the matrix 2, 3, negative 1, 1, 1, 1, and 3, negative 1, negative 1. So now I find the cofactor of A11, that is 2. So once again, we find the minor matrix of 2 as 1, 1, negative 1, negative 1. So which is equal to negative 1 plus 1 equal to 0. Similarly, the cofactor of 1, 2 is negative of a minor matrix of 3. So the minor matrix of 3 is we remove the first row and the second column. We can get 1, 1, 3 and negative 1. So which is equal to the negative of negative 1, negative 3 equal to negative of negative 4 equal to the positive 4. So next, similarly, you can find the cofactor of A13. So the cofactor of A13 is the positive of the minor matrix of minus 1. So therefore, the cofactor of the negative 1 is we remove the first row and the third column. So you can get 1, 1, 3, negative 1 equal to negative 1, negative 3 equal to negative 4. So now once again we find the second row, the cofactor of A21. So we start the negative of the minor matrix of 2. So what is the minor matrix of 2? So now we remove the second row and the first column. Sorry, we find the minor matrix of 1. So the second row and the first column. So therefore we can get 3, negative 1, negative 1 and negative. So we can get the negative of negative 3 and negative 1. Negative into negative positive. As per the rule, you can use one negative. So therefore negative 1. The answer is positive 4. So similarly, we can find the cofactor of A22. So the cofactor of A22 is positive of 1, minor matrix of 1. So that time you remove the second row and the second column. So therefore we can get 2, negative 1 and 3, negative 1. So you can get negative 2, positive 3. So you can get 1. And the cofactor of A23 equal to negative of the minor matrix of A23. The minor matrix of A23 is, we remove the second row and the third column. So we get 2, 3 and 3, negative 1. So that is the negative of negative 2 and negative 9. The answer is negative 9 times negative. So positive 11. The cofactor of A31 equal to the positive of the minor matrix of 3. The minor matrix of 3 is, we simply remove the third row and the first column. So you can get 3, negative 1, 1, 1. So 3 times 1, you can get 3. And 1 times minus 1 is negative 1. Negative into negative is positive. So once again, you can get 4. And the cofactor of 3, 2 is the negative of the minor matrix of the negative 1. So this time you remove the third row and the second column. So you can get 2, 1, 2, negative 1, 1, and 1, which is negative of 2. The negative into negative positive. So therefore 2 plus 1 equal to negative 3. And finally, you find the cofactor of A33 equal to the positive of the minor matrix of negative 1. So this time you remove the third row and the third column. So third column and the third row you remove. The remaining you can get 2, 3, 1 and 1, which is equal to 2, negative 3. So the negative 1. So from this cofactor, you arrange all the values. So therefore, the cofactor of A equal to, you write the row wise. The first row A11 is 0, A12 4, A13 negative 4, A214, A221, A23 11, A31 is 4, A32 is negative 3, A33 is negative 1. But we need adjoint of A. The adjoint of A is the transpose of cofactor of A. So we take a transpose of the given cofactor. So 0, 4, negative 4, 4, 1, 11, 4, negative 3, negative 1, the transpose. What is transpose? The transpose of A means we interchange the row and the column. The columns are replaced by the corresponding row. The first column is replaced by the first row, and second column is replaced by the second, and third column is replaced by third row. So therefore we can write 0, 4, 4, 4, 1, negative 3, negative 4, 11, negative. So we can get adjoint of A equal to 0, 4, 4, 4, 1, negative 3, negative 4, 1, 11, negative 1. Therefore, A inverse equal to 1 by the determinant of A. The determinant of A is 1 by 16 into the adjoint of A. The adjoint of A is 0, 4, 4, 4, 1, 3, negative 4, 11, negative 1. So this is A, but we need a x value, that x equal to the inverse of A into B. So you know the inverse of A, 1 by 16 times 0, 4, 4, 4, 1, negative 3, negative 4, 11, negative 1 times we multiply with the B matrix. The B matrix value is taken from the given question, the 9, 9 and negative. So if you want to multiply any two matrices, the first matrix of number of column must be equal to the second matrix of number of rows. So the order of the first matrix is 3 by 3. The second matrix is 3 by 1. So these are equal. So you can eligible to multiply these two matrices. So 1 by 16 you take outside. Then we multiply. How to multiply? The first column and first row. So the first row is 0 times 9 plus 4 times 9 plus 4 times negative 1. So the resultant matrix you can get once again 3 cross 1. So second row 4 times 9 plus 1 times 9 negative 3 times negative 1. And third row you can get 4 times 9 11 times 9 negative 1 times negative. So which is equal to 1 by 16 of 0 plus 36 negative 4, 36 plus 9 plus 3 minus 36 plus 99 plus 1. So you simplify, you can get the solution. So that means, so now we find the value. So 36 minus 4, so you can get 32. And the 36 plus 9 plus 3 equal to 48. And third one, minus 36 plus 99 plus 1 equal to 64. So now each one can divide with 16. So therefore you can get 36 divided by 16. That is x value. X equal to 36 divided by 16. And y value is 48 divided by 16. And the z value is 64 divided by 16. So 32 divided by 16 is equal to 2. 48 divided by 16 equal to 3. And 64 divided by 16 equal to 4. So therefore, the solution of the given linear equation is x equal to 2, y equal to 3, and z equal to 4. So this way you can find the solution of linear equation by using matrix inversion method. Now we're going to solve the same problem by Grammar's rule. What is the Grammar's rule? So the Grammar's rule is the x value equal to delta x divides the delta, y equal to the delta y divides delta, and z equal to delta z divide delta. What is delta? The delta is the coefficient or determinant of the coefficient of matrix. So simply we write the delta means the determinant of A. You know how to arrange the A matrix. So A matrix is the coefficient matrix. So that is you take 2, 3, -1 and 1, 1, 1. Second row. The third row is 3, -1, -1. So once again we expand the matrix with row wise. So I take 2, the minor matrix of 2. How to find the minor matrix of 2? You remove the first row and the first column. You can get the value 1, 1, -1, -1. So 1, 1, -1, -1. Then negative of 3. So now we find the minor matrix of 3. So that means you remove this first row and the second column, the number containing row and a column you can remove. So we can get 1, 1, 3, -1. And once again, the positive of -1 is the once again find the minor matrix of -1, that is A1, 3 place. That means we remove the first row and the third column 1, 1, 3, -1. So now we explain the matrix. Once again, we recall how to explain the minor matrix of 2 by 2. So if matrix is of the form A, B, C, D, then you write AD minus BC. So therefore, I can write 2 times the -1 of -1, +1, -3 of -1, -3, and -1 of -1, -3. So 2 times of 0 is 0. The -3 of -4 and -1 of -4, which is equal to 12 plus 4 equal to 16. So the determinant value is 16. So which is not equal to 0. So therefore you can eligible to solve by Gramer's rule. Now we're going to find the delta x value. The delta x value means from the determinant of A, you replace the coefficient of x by the matrix B value. What is matrix B? 9, 9, and -1. The first column is changed 9, 9, -1. That is 9, 9, -1. The remaining second and third column we keep as it is 3, 1, -1, -1, 1, -1. Now we expand this matrix as per the row wise. So therefore 9 of the minor matrix of 9 is 1, 1, -1, -1. Then -3 of the minor matrix is 9, 1, -1, -1. And the minor matrix of the -1 is, we remove the first row and third column. So you can get 9, 1, -1, -1. So now we expand. So 9 times, you know how to expand any minor matrix. A, B, C, D is a minor matrix. You know the value AD minus BC. So that way, once again, you expand the -1. The negative of negative is positive. So therefore, we can get the +1. So -3 of -9 and +1, then -1 of -9 plus +1. So you can get 9 of 0 and -3 of -8 and -1 of -8, which is 24 plus 8. So 24 plus 8 is 32. So the delta x value you can get 32. So similarly, you can find delta y and delta z. So what does delta z? The delta z is you replace the coefficient of z by the matrix B. What is delta y? You replace the coefficient of y by matrix B value. Similarly, we can find delta y and delta z value. That is delta y, we replace the coefficient of y, and delta z, we replace the coefficient of z. So we can get the delta y is 48 and the delta z is 64. So once again, we substitute the values in the formula. So therefore, x equal to the determinant of delta x divides the determinant of delta, so equal to the 32 divided by 16, so you can get 2. Similarly, delta y equal to the determinant of delta y divides the determinant of delta, so you can get 48 divided by 16, so you can get 3. And delta z equal to the determinant of delta z divided by the determinant of delta. So we can get 64 divided by 16. So we can get 4. So once again, we can get the same value of x, y, and z. So x equal to 2, y equal to 3, and z equal to 4. So if you are using any method, that is either a matrix inversion or Cramer's rule, you can get the same solution. Thank you.